Let us start to learn third trigonometric function, that is tangent function y equal to tan x. First we will see the table for drawing the graph of tangent function. If you observe this table, then here x is equal to 0, x equal to pi by 6, pi by 4, pi by 3, means the values of x are going on increasing from 0 to pi by 2. When x equal to 0, y equal to 0. For x equal to pi by 6, tan pi by 6 is equal to approximately 0.58. But we know that tan pi by 4, that is 45 degree. Tan pi by 4 is equal to 1. Tan pi by 3, that is tan 60, is equal to 1.73. Tan 4 pi by 9 is 5.67. Tan 17 pi by 36 is 11.43. And we know that when theta is equal to pi by 2, that is 90, we can't find the value of tan 90, so it's undetermined, means infinity. So tan 90 is equal to infinity. So as x increases, y also increases. Now we will start to draw the graph of tangent function with first part from 0 to pi by 2. In this part, when x equal to 0, tan is equal to 0, so we get first point, that is the origin. Second, when x equal to pi by 6, that is 30 degree, then tan 30 is equal to 0.58, so we get the second point. Third, when theta is equal to pi by 4 or x equal to pi by 4, tan pi by 4 is equal to 1, so we get third point having coordinates pi by 4, 1. Let us see fourth one. When theta equal to pi by 3 or x equal to pi by 3, tan x equal to tan pi by 3, that is equal to 1.73. So that point lies between 1 and 2. So that will be our fourth point. Then if you take the value of x equal to pi by 4, then obviously y equal to tan pi by 4 is not defined. So there is no point for this x. So whenever we will take x equal to pi by 2, there is no value of y. So the graph of tangent function does not touch the line parallel to y-axis, that is x equal to pi by 2. Let us see the remaining portion of this branch of y equal to tan x from minus pi by 2 to pi by 2. Now we will see the points in the interval minus pi by 2 to 0. When x equal to minus pi by 3, that is minus 60 degree, then y is equal to negative of 1.73. When x is equal to minus pi by 4, that is minus 45 degree, then y is equal to minus 1, because tan pi by 4 is 1, tan minus pi by 4 is minus 1. Also when tan theta is equal to or x equal to minus pi by 6, that is minus 30 degree, then y equal to minus tan minus 30 is equal to minus 0.58. So in this case we get 3 more points, so that here we get 3 lower points, means points below x-axis, and 3 points above x-axis, and 1 origin. So taking these 7 points, we can determine the position of graph of tangent function. The most important point to remember here is that if you observe the graph of tangent function from minus pi by 2 to pi by 2, then the graph is only increasing. Now we will see second graph of the same tangent function. Here the interval is taken 0 to 2 pi. Here the points are shown by red dots. First point is origin 0, 0. Then the first branch of this tangent function is from 0 to pi by 2. Again, for x equal to pi by 2, there is no y. Second part is from pi by 2 to 3 pi by 2. 3 pi by 2 means 1.5 pi. And third part is given from 1.5 pi to 2 pi, that is 3 pi by 2 to 2 pi. Once again, in each part, the graph of tangent function is only increasing. Another point to note that the graph of tangent function cuts x-axis at 0, 0, at pi 0, at 2 pi 0, etc. at 3 pi 0, 4 pi 0. Similarly, it will cut the x-axis at minus pi 0, minus 2 pi 0, minus 3 pi 0, etc. And these points are nothing but the x-intercepts of tangent function. Now see this extended graph of tangent function. Here, if you observe, then three full branches of tangent function are given. Those are minus 3 pi by 2 to minus pi by 2, minus pi by 2 to plus pi by 2, and plus pi by 2 to plus 3 pi by 2. Again, the same point is here. The intercepts on x-axis, the branches or curves of tangent function intersects the x-axis at minus 4 pi, minus 2 pi, minus pi, 0, plus pi, 2 pi, 3 pi, 4 pi, etc. Means the x-intercepts of tangent functions are the all integral multiples of pi. That is, we can call it as n pi, where n is an integer. Now let us see the properties of this tangent function. For that we will see another graph of tangent function. Now we will see the four important properties of function y equal to tan x. First one is about domain. Here domain is nothing but the values of x. Here all real values of x belongs to this domain except integral multiples of pi by 2. That means minus 3 pi by 2, minus pi by 2, plus pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2. These are all integral multiples of pi by 2. So these values does not belongs to domain. So domain is the set of all real values except integral multiples of angle pi by 2. Okay. Now let us see second one, that is the range. Range is nothing but the values of y. If you observe the graph carefully, then every value of y belongs to this range. So range is the open interval minus infinity to plus infinity. Now see the third property about period. Once again observe the parts of this graph. The central part of this graph is between minus pi by 2 to pi by 2. So the one branch of this graph lies in between minus pi by 2 and pi by 2. So the period of this tangent function is pi. It means it completes its one cycle in the interval minus pi by 2 to pi by 2. Therefore its period is pi. Similarly, we can observe the remaining cycles of the tangent function from pi by 2 to 3 pi by 2 or minus 3 pi by 2 to minus pi by 2. So the period of tangent function in each cycle is pi. Now see the fourth property about asymptotes. Asymptote is a straight line that continually approaches a given curve but does not meet it at any finite distance. Here we are observing the vertical asymptotes. These vertical asymptotes are nothing but the lines which do not touch the tangent function. Here x equal to pi by 2, x equal to 3 pi by 2, x equal to 5 pi by 2, x equal to minus pi by 2, x equal to minus 3 pi by 2. These are the lines which do not touch or intersects the graph of tangent function. So these lines are called as the asymptotes of the function. Now let us see the remaining properties of tangent function. Before this we have learned the property about domain, range, x-intercept and y-intercept. Now let us see the continuity. This function y equal to tan x has infinite discontinuities at x equal to pi by 2 plus n pi, where n belongs to integer. It means it is discontinuous at the integral multiples of pi by 2. Once again, the equations of asymptotes are nothing but the lines which are parallel to y-axis and do not cut the tangent function. So these lines are x equal to pi by 2 plus n pi. The symmetry of this function is only origin, as it's an odd function. Therefore origin is the point of symmetry. It means if you want to find the image of certain point, then draw a line passing through that point on the curve and origin, then that line will cut the function or graph in one point or many points, but out of those many points, one point will be the image of that given point. Therefore, the graph of tangent function is symmetric with respect to origin O. Here, the value of y tends to infinity. That means here is no extrema. It means the function is unbounded function because it has no lower bound or upper bound. Now the last is end behavior of the function. Here the limit of tan x as x tends to minus infinity and limit of tan x as x tends to infinity, we can't define that limit. It means they do not exist. Therefore the function oscillates between negative infinity and positive infinity. Now let us see the graph of cotangent function, that is y equal to cot x. As cot x is the multiplicative inverse of tan x, that is cot x equal to 1 upon tan x. So taking the reciprocal values of tan x, we can find the corresponding values of cot x, and by plotting the points we will get the graph of cotangent function as shown here. Always note one important point here is that tan 0 is equal to 0, therefore the graph of tangent function passes through origin. But cot pi by 2 is equal to 0, therefore the graph of cotangent function passes through pi by 2 0. It means the graph of cotangent function do not pass through origin. Here red colored curved lines shows the graph of y equal to cot theta or y equal to cot x. By observation, we can easily conclude that the graph of cotangent function is decreasing in the particular intervals, that is between 0 to pi, pi to 2 pi, pi to 3 pi, minus pi to 0 or minus pi to minus pi, also minus 3 pi to minus 2 pi, etc. Now the domain of the cotangent function is a set of all real theta or x except the integral multiples of pi. It means when theta is equal to 0, plus pi minus pi, plus 2 pi minus 2 pi, plus 3 pi minus 3 pi, then there is no point of intersection of cotangent function at these points. Therefore the domain is a set of all real angles theta except the integral multiples of pi, and the range is nothing but the values of y. Here y has all real numbers minus infinity to plus infinity. Therefore the range of cotangent function is open interval minus infinity to infinity or a set of real numbers r. Now in this graph, the blue color dotted vertical lines are the lines which do not touch the graph of cotangent function, and these lines are known as the vertical asymptotes of cotangent functions. These lines are at the point on x-axis where the x coordinate is the integral multiple of pi. Therefore these lines are parallel to y-axis and they pass through the points which are the integral multiples of pi. Therefore their equation is nothing but x equal to n pi, where n is an integer. The x-intercept of cotangent function is at x equal to 2n plus 1 times pi by 2. It is nothing but the odd integral multiple of pi by 2. It means the point at which the curve or branches of cotangent functions cuts x-axis, and in this diagram you can easily see those branches or those points are nothing but minus 3 pi by 2, minus pi by 2, plus pi by 2, 3 pi by 2, 5 pi by 2, etc. So those are in general written as x equal to 2n plus 1 times pi by 2. If we observe each branch of cotangent function, then the curve or graph of cotangent function is only decreasing in each branch. Let us see the period of cotangent function. If you observe each branch of cotangent function, then the first branch is principal branch and it is between 0 and pi. Second branch is from pi to between pi to 2 pi. Third branch is between 2 pi to 3 pi. Also to the negative side, the branch is between minus pi to 0, minus 2 pi to minus pi. So each branch is between a period of pi. It means cotangent function completes one cycle during the period of pi. Therefore its period is pi. Similar to tangent function, the cotangent function is also odd function. Therefore it is symmetrical with respect to the origin O. Now see the graphs of tangent function and cotangent function in the same graph paper. The violet blue line indicates the graph of tangent function and green line indicates the graph of cotangent function. Tangent function passes through origin, but cotangent function passes through pi by 2, that is 0.5 pi. You will get very nice design if you draw these two graphs on the same graph paper with colored pencil. In this figure, we are observing the graphs of three trigonometric functions: sine function, cosine function, tangent function. Here the graph of sine function is shown by red curved line. The graph of cosine function is shown by blue curved line, while the graph of tangent function is shown by yellow curved line. Now after learning the information about the trigonometric functions, their properties and graphs in our previous 3 lectures, now let us see an interesting animation about these 6 trigonometric functions. Here the point is moving along the standard circle. It moves from first quadrant to second quadrant, then to third quadrant, and lastly to fourth quadrant. The same quadrants are shown in the graph as first quadrant from 0 to pi by 2, second quadrant from pi by 2 to pi, third quadrant from pi to 3 pi by 2, and fourth quadrant from 3 pi by 2 to pi. So as point moves on the circle, it also moves on the curves of all trigonometric functions, and we can easily observe the intersection of the curves at the particular points. If you stop the video at a particular point, then for that particular angle you can easily observe the position of points on all the trigonometric functions at the same time.